EG4 Electronics solar powered mini split troubleshooting. If you've bought an EG4 Electronics solar powered air conditioner, you've installed it but it's not working, today I'm going to give you some guidance and help you to troubleshoot, give you the necessary tools that you're going to need and the steps so that you can maybe figure out what's going on and you can get this EG4 Electronics mini split back up and running. You're watching Taddy Digest. I'm Tad. Let's get started. You need a multimeter. This is a Fieldpiece meter. It's a little over $200 and it has a clamp for measuring the current. You don't have to have this type of meter. You can have a Tesmen meter. This is a very affordable meter. I'll put the link in the description for both. You can decide what meter you need. And then you want to figure out, is the unit coming on at all? If it's not coming on at all, we need to start from the basics. We need to start by measuring the power input to the equipment, and that's what we're going to do. Now, for taking the panel off, you're either going to need a cordless drill with a Phillips bit, or you're going to need a Phillips screwdriver. And we're going to start by taking the panel off so we can get to the electrical connection. Now that we've got the cover off for the electrical connections, we've got L and N, and this is where our AC power wires into the unit. So you should have 115, 120 volts when you measure between L and N. Then you've got 1 and 2. 1 and 2 is where you should measure your power coming from the outdoor unit to the indoor unit, which we're going to check in a moment. And then 2 and 3 is where you should measure some DC communication. This is communication that's provided from the communication board from the outdoor unit to the indoor unit. Now we've got two power sources. We've got our PV MC4 connectors, and this is where your solar panels would be connected into these PV wires and then into these MC4 connectors. And you can use the DC, but when there is no sun and there is no PV power, then you're going to be using AC. So I'm going to show you how to measure the voltage next. Now I'm going to show you how to use the Tesmen meter. So you push the button in the middle, which is red. That's the power button. It's going to say auto. You have the ability to read DC and AC. You don't have to set a dial for a certain symbol. On this one, you can go from L to N, and if you have AC power, you'll see it displayed. So I've got 121 volts. Now, if you go from 1 to 2, it's going to display the DC volts, right? 372 volts. Then from 2 to 3, it should be jumping around because this is our communication. So you see it's not staying steady. Now, how do we know when we're using AC or DC power? Let me show you. Now, for the Fieldpiece meter, I'm going to AAC. I'm going to hit the select button, and then I can take and put my clamp around one of the wires that goes to L or N. And then if we're using AC power, then you're going to see maybe 3 amps, 4 amps, 5 amps, however much current we're drawing will be displayed on the display of the meter, and we'll know we're using our AC power. So when the sun's up and we got plenty of PV power, right? We got plenty of DC power. Then this equipment is going to utilize the DC power. Whenever the sun goes down or we don't have any PV power, there's no DC volts going to our unit, then it's going to switch over automatically and it's going to use the AC power. If the equipment's not doing anything, you need to check the power first. And if you don't have power, then you need to check your power source. Let's talk about what else can be wrong. Now, if the equipment's running and then it's shutting off, it's only running for a few seconds and then shutting off, one thing you need to check is you need to check your valves. Make sure you have a Phillips screwdriver and you take off this cover, and then you want to have an Allen tool, and then of course an adjustable crescent wrench. So what you want to do is you want to take and open up the service valves, the caps for the gas pipe and liquid pipe service valve, and you want to take and open these up all the way. And if they're opened up all the way, then that means the refrigerant can flow. So make sure they're open. You'll want to turn them counterclockwise to open them, or to the left. So counterclockwise. Clockwise is going to turn them to the right, and that is going to close the valve down. But if the refrigerant can't flow, then that's going to cause the unit to not work properly. So that's the second thing you're going to want to check. First was power. Second, make sure the service valves are open. Now that the unit's running, I'm going to show you that it is drawing current. So we're going to wrap our clamp around one of the wires and take a look. 3 amps, that's what you're going to see if it's using the AC power. If the unit's coming on, but it's not heating and it's not cooling, but the outdoor unit's running, you may need to check the refrigerant pressures. So get a set of gauges. I'll put a link in the description to this set of gauges. You'll also need this fitting. This is a 1/4 inch to 5/16 adapter. And you'll need this to actually put your gauges or your hose connected to this service access fitting right here. So here's the service access fitting, and I'm gonna screw on that adapter piece. That's 5/16 to 1/4 inch. And then we're gonna take, and we're gonna use our low side gauge during cooling, and then we'll use our high side gauge during heating. Now, why would I say that? I say that because during the cooling operation, this is your low pressure pipe, right? Your suction pressure pipe. And it's going to have a low pressure, sometimes 100, sometimes 150. But during the heating, this line is not going to get cold, it's going to get hot, and it's going to be referred to as the hot gas line. And it can have pressures upwards of 400, and this gauge only goes up to 350. This is the low side gauge, this is the high side gauge. So I'm going to connect my low side hose during the cooling operation. So we can see while the unit's running, it's about 125. And this is a typical pressure you're going to see during the cooling operation. Now, the pressure will change depending on the outdoor conditions. But again, remember, during the cooling operation, you're going to hook up the low side hose, which is blue, and the low side gauge. During the heating operation, you're going to hook up the high side gauge and the high side hose. And you're going to need a 1/4 inch to 5/16 adapter. During the cooling operation, the larger line is going to be cold and sweating, and during the heating operation, this line is going to be hot to the touch, and I'll explain why. Here's another tool you may want to have. This is a temperature clamp, and then this is a meter, and I can turn this to where it says FC, which is Fahrenheit Celsius, and I can take this clamp and I can put it right here on this line, and it'll show me the temperature of that line. And typically it's going to be in the 50-degree range when it's in cooling, and then when it's in the heating mode, it could be upwards of 130. So this is something you can utilize. I'm going to show you some more tools as we move along. Now we've got the equipment in the heating operation, so it's in the heat mode, and I want you to see the pressures. This is the high side hose hooked up now with the high side gauge showing 300 psi. So we got a pretty high pressure, and that's the reason we want to use the high side gauge and the high side hose during the heating operation. Now I want you to see that with this clamp hooked up and our meter, you can see that the temperature it's still rising, but it's 87 degrees, 86 degrees. So this line is hot during the heating mode, and that's the larger line. Before we go inside, make sure you size your breaker properly. See how it says max fuse, 20 amp? That means we need a 20 amp single pole breaker. We can never go above that number. We can never put a 25 or a 30 amp breaker on this unit. And if it was 230 volt, it would require a double pole breaker. You can put a 15 on this unit, but you cannot put over a 20 amp breaker. That would be very dangerous. So you want to make sure you adhere to the max fuse of the equipment. This is a 12K model, so it's 12,000 BTU or 1 ton, and that means it'll heat and cool about 500 to 600 square foot. As far as wire size, we would need a 12-2 wire for wiring up this equipment, so 12 AUG. Now we want to check the transmitter or the remote controller. This is the wireless remote controller, and there are batteries that are required for you to be able to see this display. If you have not put the batteries in, please put them in. And to check the transmitter, there are 2 things you're looking for. One is you have to push the button and get your camera, and then when you push the button, you're going to see a purple light. You see that purple light? That means it's working. Also, you want to push the button and you want to hear the beep. When you hear the beep, then that means that the receiver is receiving the transmission. And if your unit is not doing anything inside, it could be that either A, you don't have that purple light, which means you may need to put the batteries in, or you may need to replace the remote control. If you see that light and your batteries are in, then it could be the receiver. And then we would need to check and make sure it's actually plugged in. Now, I want to show you something else that I've seen in the field that causes a problem with the equipment working. And it's not common, it's very uncommon, but it can still happen. So we're going to check the power from the outdoor unit to the indoor unit. And the way we're going to do that is we're going to take the front cover and lift it up, and this is how we would get to our filters. And then we're going to take the Phillips screw out of this cover right here that covers the terminals where we connect our power cable. So now that we can see the 1, 2, 3, I'm going to show you what to do with your meter. Now we're going to use our multimeter, and we're going to measure the power coming from our outdoor unit to our indoor unit. We're going to place our leads on 1 and 2, and you can see it's 250 volts, right? So we have power coming into our indoor unit. Then we're going to measure from 2 to 3, and that's our communication. See how it's jumping around, 11, 13, 12. Now let me talk to you about what can happen. A uncommon problem, but it can be a problem. When you're installing this equipment, the power cable that comes from the outdoor to the indoor unit and wires up to terminals 1, 2, and 3, during the process of installation, I've had technicians that have stepped on that wire or cut that wire somehow. Sometimes it can even trip the breaker. But whenever you measure voltage at the outdoor unit and you don't measure voltage at the indoor unit, check out your wire. Maybe unwire all of it and then ohm it out, and then see if you can measure continuity through the wire. And if you can't, then the wire is bad. You need to get another cable. That way you can have good power from your outdoor to your indoor unit. These terminals are labeled for a reason, and these wires are labeled as well. And that's so that you do not cross one of the wires. Meaning, if you put the brown wire to the terminal labeled 1 at the outdoor, it needs to be at the terminal labeled 1 at the indoor. Because these are polarity sensitive, you do not need to put the blue on 1 and then the brown on 1 at the indoor. The unit will not work and it can damage something. Before we move forward, if you see Celsius on your remote controller, you can change it to Fahrenheit by pushing the temperature up and down buttons at the same time. And you'll be able to utilize that to be able to switch from Celsius to Fahrenheit. Also, people get confused with cooling and heating symbol, which is which. Cooling is the snowflake. Heating is the sun symbol. Now I'm going to explain the operation of the equipment. If you turn the equipment to the cooling mode, the indoor fan is going to come on almost immediately. The outdoor unit takes around 3 to 5 minutes to come on, and then it should start blowing out cold air. This is the return, and this is the supply. And usually the temperature difference between the return and the supply is around 20 degrees. So you'll have a 20-degree split, meaning if it's 70 degrees inside your building, then that means out of this vein here where the supply air blows out, it should be around 50 degrees and sometimes even lower. Now, during the heating mode, it's the opposite. If you turn the equipment to the heating mode, the indoor fan will not come on until the temperature of that coil reaches a certain point. After reaching a certain temperature, then the indoor fan motor is turned on, and then it starts to blow warm air. The reason it's not just turned on as soon as you turn it into heat mode is because that would be uncomfortable, because it would just be blowing room temperature air. So this is just more comfort for you. If you ever see the screen display LP, that means low power. So if you're just powering your solar powered mini split with your PV power, your solar panels, then whenever you don't have the sun and you don't have PV power, then you're going to have LP displayed, and the equipment will not run if it doesn't have sufficient power. So the remote controller is what you can use to set your target temperature or your set point temperature. This sensor right here is known as the ambient air sensor or the room temperature sensor. And this is a thermistor that's 10 kiloohm. And whenever the air passes into this return, then it passes across this sensor. And this is what tells the unit what temperature it is in the room. So if you have a faulty sensor and you try to use the cooling mode, and maybe this sensor is telling the equipment that it's 30 degrees in here, that may be the reason the unit's not working. Or maybe the sensor is saying it's 150 degrees in here, and you're trying to use the heat mode on your remote controller, but the equipment's not running. You may need to use a meter and check this sensor, and I've got videos that show you how to check these sensors and how to use a resistance chart. Now I'm going to talk about maintenance. So we need to make sure we pull our filters out and we wash our filters. That's really important, right? It's very easy. You pull the filter out, you wash it, you let it dry, you put it back in. Then if you ever hear rattling, if you ever hear vibration, if this unit's ever making a terrible noise, I'm going to show you where to check. So right here is where our blower wheel is. It's up there. So if you ever hear a noise, then it could be that your blower wheel is dirty. And sometimes I'll see these mini splits where the coil is not even dirty, right? But that blower wheel is packed. And whenever it gets packed and whenever it doesn't get cleaned, then that causes the bearings in the motor to go bad. So you need to periodically go up here with a flashlight, make sure the unit's off, and check that blower wheel. And if you want to know how to clean one, I'll put a video down in the link so you can learn how. Now, the last thing I need you to know for maintenance. Come outside where your line sets and your drain pipe exit the exterior. Take a shot vac and put the end of the hose right here on the drain pipe. Suck out the drain annually once a year. And I'm going to talk about what happens if you don't. If you don't suck out the drain every year, then the drain could be stopped up and then water will pour down your wall. So if you ever see water pouring out below your wall mount air handler, go check the drain, use a shop vac, and clear it out. Let's say you've had this equipment for a couple years, and one day you come into your house and it's just not getting warm like it used to, or it's not getting very cold like it used to. You can use a dual induct psychrometer like this, and you can actually measure the supply air temperature. Make sure you don't put the probe too far inside the actual air handler because you do not want to stick it inside the blower motor's wheel. Then you may break it. But you can see it's blowing in the 50s. That's really nice. This is something you can use. And what if it's not blowing cold? What if I put it up there and it was blowing out room temperature air? Then what would I do? Come out to where the outdoor unit is located and see if it's operating, see if it's running. If it's running, see if this larger line, known as the suction line, see if it's during the cooling operation, if it's cold. See if during the heating operation that it's hot. And if it's not, then you may need to hook up your gauges. You may need to check and see what the pressure is, because if the unit's operating, what if it's in the cooling and you've only got 50 psi? Then we need to make sure the indoor fan is running, and if it is, then we may be low on refrigerant. Now, what you need to know for adding refrigerant is you never want to really just add refrigerant unless you're measuring the temperature here and you're in the cooling operation. You're really going to have a hard time adding refrigerant in the heating operation, and I don't recommend it. But what I do recommend is reading right here where it says refrigerant, 1.1 kilogram or 38 ounces. This right here is the factory charge. So the proper way to add refrigerant would be to recover what's in here, see what it is when you weigh it out. If it's 12 ounces, then you know you need refrigerant. Then you can figure out where the leaking area is, and then you can factory charge it back up to what is standard, which is 38 ounces. If you need a good leak detector, I'll put a link in the description to one that you can utilize. And if you want to make sure you don't have leaks, you need to make sure that you use a digital torque wrench, because inside the user manual, you'll be able to see the values that you use for torquing those connections. And if you use a torque wrench, then you can ensure that you're going to have a less of a likelihood of having a leak. If you need to call tech support, make sure you have as much information about your equipment as possible. Make sure you have the model and serial number of the equipment ready. Make sure you know if you're just using DC as your power source or you're using AC and DC. And also make sure that you pay attention to whether your unit is working in just heating or just cooling. That way you can give them that information and they can better help you. If you want more information, maybe an advanced course on EG4 electronic solar powered air conditioner, let me know in the comments and I'll do an advanced version of this video and give you even more information, give you tech tips and troubleshooting as a technician in the field to be able to handle advanced problems that you may have with this solar powered air conditioner. If you're looking for a solar powered air conditioner, go check out Signature Solar and use discount code TADDY50 for $50 off your order, anything over $500. I hope you enjoyed the video. I hope you liked it. If you did, hit the like button, subscribe, and smash that bell, ding, so you know what I'm doing. If you learned something, let me know in the comments what it was. If you got a question, please ask the question, because questions can lead to new content. And if you don't have a question, that's okay. Let me know who you are and let me know where you're from. You've been watching Taddy Digest. I'm Tad, and I'll keep you cool if you let me.